Okay, we're back again. We're going to answer the activities regards with the chapter 7. So let's start with the binary to decimal conversion activity. So at first, as you can see, the missing one or the missing are the decimal value, and we need to know or we need to distinguish what is the decimal value of the bit, corresponding bit and position at the downside of the activity. So let's start. We're going to add all ones or all representing the bit with 1. We have the 128, the 2, the 4, and the 16. So let's start with the 130, 134, 40. We have 150. So you can see we are correct. Okay, for our next activity, and this is not this is quite different with the first activity. This is needed the bit and the decimal value is given. We have our given value, and now we're going to distinguish the binary value of the decimal value given. We have 211 there, so 1, 64 is also 1, 128 plus 64, the 168, 188, 190, 192 plus 8, 200 plus 16, 208. We have 2 and 1. Oh, now it's correct. The the binary value of the course of the given decimal value is 128, 64, 16, 2, and 1. So let's go with another activity. So here's our next activity, ending to determine and network addresses. We have to determine the network addresses, the binary, and the decimal. So we'll start with the binary. Going to copy the given we have to copy all the 1, similar with the network binary. One zero, so it is 0, and the other side is 0. Then for our network decimal, we have 1 plus 2 plus 8. We have 11. And 8 plus 16, we have 24. We have 0 here. And here, 0. Wait, there's a typical error here. It is quite difficult to type with a cell phone, and I'm going to write it first. Was I become wrong, so I found out that some typographical error here. So sorry. Eight 16. Is it wrong? Puta. Oh, it is wrong. 8, 1, 2, 4, 8. 12 here. Oh, it is correct. Oh, this is our another activity. Unicast, broadcast, and multicast. So determining the IP address given, if where is the destination of its IP from our source. So let's start. 237.192.17. I have here this device and this device. So start 192.168.100.2. So we have only one device here. So you have successfully identified the transmission type. So we'll try it again. In order to be fluent with this kind of activity, kind of knowledge, so we have this and this. We have two devices. Yes, we are correct again. So let's try it at the third time. 192.168.100.2. We only have also one device here. So it's correct again. So let's go to our another activity. For another activity, we need to pass or block IPv4 addresses. Let's know if it's pass. Oh, it's pass. Block. Why it is stopping? So reset. Pass. Pass. Block. Pass. 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 Oh wait, stopping. Block. Pass. There's another activity. We have there's the issues and solution. We have the description, and we're going to find the terms of its description. We have the 128-bit address or the 343 undressilion addresses, it is specified as IPv6. IPv4 is the 32-bit. Then the transport in IPv6 packets, it is the translation use not exception but between IPv6 and IPv4. Then allows IPv4 and IPv6 to coexist some network segment. It's the dual. That's correct. Another activity here. Have to find. So we have the 201. Here's 0, DB8, and they have here the triple 1, quadruple 1, and this is a 0, 0, 0, and 200. And by compressing the format, you have 2001, 0, DB8, 111, 0, 0, 0, 200. So it's the compressed format of all. And I'm going to find again another activity here. There is more activity. So at here, the identify types of IPv6 addresses, we have the global unicast first, link, another global, and then the 64, and link local. So it's check, now it's all correct. And find another activity here to be the more faster process. So we don't have activity, so thank you.